This video is focusing on AS hypothesis testing, critical regions. We're looking at the binomial distribution and the hypothesis test that goes with the binomial distribution. If you haven't read this part of the notes, I suggest that you pause the video and have a look at it. I have highlighted some of the key information within this section. So if we just have a look at the words, so critical region is the bit that we're looking for. That will be given to you in the question. If you see the words critical region, you must use this method in order to solve the problem. This method can be used for all hypothesis testing, so it might be that some of you prefer to just use one method, then just use this one. If the value falls within the critical region, so we're talking about the evidence that we're given in the question falls within the critical region, that means that we're going to reject the null hypothesis. If it doesn't, it falls in the area called the acceptance region. And if it falls in there, then we're going to fail to reject the null hypothesis. So they're the key points that we need to get round. We're going to use the significance level in order to work out what that critical region is. Again, the significance level will be given in the question, and that is giving us the probability of being in that area. So we're looking at very small probabilities, generally 5% is what we're working on. Because it's a discrete distribution, what we can do is we can draw this as a diagram. And because it's discrete, it would have vertical lines. So it would look something like this. It might have some probability at that side. So if we were doing a binomial distribution, because it's discrete, these are integers. So we've got 0, 1, 2, 3, 4, 5, 6, and 7 going up there, etc. The critical region would be for this, because we're looking at a top tail, so one tail test would be somewhere up here, and we're looking at the small probabilities that we're adding together. If we're looking at the lower end of a tail, your distribution would have small probabilities down here, and it would look something like this. If you're not sure about the diagram, maybe just have a look back at chapter 6, where we just before we started the binomial distribution, and we looked at discrete distributions, the uniform distribution. This is just an extension of that, really. So if we were looking at the critical region, it's going to be the bottom end for that, the top end for that. Moving on to the next page. If we have this binomial distribution, so we've got n is fixed, in this question 10, and the probability that we are testing is 0.4. So that is given as the null hypothesis. This is the graph of that binomial distribution. Notice that we've got the expected value. So the expected value is found by taking how many trials we are doing and multiplying it by 0.4. If I was going to toss a coin 10 times and I asked you how many heads you would expect me to get, you would automatically say 5. The calculation you are doing there is 10 times a half, because the probability of getting a tail on a coin would be a half. So that's the calculation that we're doing. And what happens on the graph when you multiply those together, the expected value, that is the peak of the binomial distribution, because that is the most likely to happen. So these lines here are all representing the probability. The critical region then, if we have a look at it in this diagram, it's been highlighted to be 8, 9, 10, and I'll show you how to find that in a minute. What that is saying is, if we have a value of 8, 9, or 10, the probability of falling in that area is so small that suggests the model of the binomial 10 and 0.4 is unlikely to make this happen. If your evidence has happened and we do fall into that region, then that would suggest that the model is incorrect, which is the reason why we are rejecting H0 at that point. If we have a value between 0 and 7 in this distribution, then that is in the acceptance region. So we would then accept H0. We haven't got enough evidence there in order to reject it. To calculate this, you can do this on your calculator using binomial CD. So it's all cumulative. we're using the cumulative distribution. So binomial CD on your calculator, and the list is quite useful for doing this. When you're using the list, what you are essentially doing is recreating those binomial tables, but onto your calculator. For the purpose of doing this, I'm going to use the table because I've got it here and I can show you how it works. So let's just remind ourselves, when we're doing binomial using the cumulative distribution, we are starting at 0. So the table is starting at 0 and it's adding up those probabilities as it goes. So this is a less than or equal to. If I am trying to find a region where the probability is greater than or equal to a number, that's the number that I'm going to try and find, and I'm trying to make it less than 0.05, we need to just remind ourselves that to calculate this probability, I need to do 1 minus the probability that x is less than or equal to x minus 1, which we looked at when we did the binomial distribution. So that's how we're going to calculate this. Now, this bit is what most students get wrong in the exam. I think most students are quite happy using the calculator or the tables to look up the values, but they forget to do that +1 when they're reversing it. So we just have a look at this here. So this is the table. We are working with n is equal to 10. And we're on probability of 0.4. So that was what the question set up. Because we are looking for greater than or equal to a value and we want it to be less than 0.5, these are the two values that I need to consider that have got the red box around them. If we're looking at the probability that x is greater than or equal to 8, that is the same as doing 1 minus the probability x is less than or equal to 7. On the table, that would be this one here. So the probability that x is less than or equal to 7 is 0.9877. And then taking that away from 1 is going to give me 0.0123, which is less than 5%. Considering greater than or equal to 7, we've got 1 minus probability x is less than or equal to 6, which is going to give me 1 minus this value here. So that's 0.9452, which is equal to 0.0548, which is greater than 5%. Generally, we are working less than the significance level that is given in the question. So in that case, that would suggest that this is our critical region. We would write our critical region then to be greater than or equal to 8. So the critical region here is x is greater than or equal to 8. And because it's discrete and our top value is 10, that means 8, 9, 10 would cause us to reject H0. This section here, the actual significance level of a hypothesis test, is the probability of incorrectly rejecting the null hypothesis. All you have to do is read off the probability that you're given that you've just calculated in the question. So our actual significance level that we're using is 1.23. 5% was just used as a guideline. 1.23 is what this distribution is actually giving us in terms of that question. I'm going to stop this now. I'm not going to go on to the next examples. I'll do that in a separate video so that there's not too much happening here. If you need to go back through this, it might be worth just listening to this video again because there's quite a lot of information there. Otherwise, get on to the next example on the next video and I'll talk you through the examples in the notes.